Will and Edo and Mac. Kunal, we'd always miss you. Oh, we're hoping you're back on Friday. All right. Said Will. Yep. He's been away from the beginning. Then Mac and Kunal were at the same time. They've been missing, believe lost. Okay, so did we... Oops. So guys, I did the recording the other day, but I didn't bother uploading it because I just ran out of time. But anyway, we are now looking at the equation of planes and make it sure that you've got it different from the equation of a line. Equation of a line, what do we need? Right, so when we've got line, I feel like yellow today. Oh, look, nice and bright. Line, we need the direction vector and we need a point. Okay, for a plane, we need what we call nice big N. That is called the normal vector. And again, we need a point. So what do I mean by the normal vector? That is the vector that is perpendicular to the plane. You are either going to be given the perpendicular vector, they'll say this is the normal, right? Or they say it is perpendicular to blah, blah, blah. Or they will give you 3 points. Let's say they give you point A, point B, and point C. How would we find a vector that is perpendicular to this plane with these points? Well, we would find BA, we would find BC, and we would find the cross product. So BA crossed with BC will give you a vector that is perpendicular to the rest of it, right? I can see Aman with the eyes there, and she's going, yeah, but I would have gone A, B, A, C. Sure. You could do A, B, A, C. You could do C, B, C, A, right? And quite frankly, even if you did C, B, and AC, not too bad, because that would be going possibly the opposite way. It's still going to be a normal vector, whether it goes down or up, right? But when we do the angle between two lines, we always like to go from here out. So we just stick with that. We? That's probably about it. So we'll just get stuck in and apply, shall we? Because once we've got our point, the equation of any vector is when we've got our normal vector, where shall I put it? I'll go back up here. When we've got our normal vector, which is, no, we'll give it, what did they go? Little a, little b, little c? They went little b, little b, little b, little c. So A, B, C. Okay, and then we have a point. Was that capital A, capital B, capital C? I would have gone X1, X2, Y2 myself. But anyway, that's just me. Yeah, they went X, Y, Z. There you go. They went an X point, a Y point, and a Z point. We just say they've clicked it. Yeah, I don't know why I was thinking capitals. So they go A times an X, right? Just the X, because you need 5X, 2X, 3X, 7X, whatever. Then B times your Y value. You guys should have all of this down already. It's the people at home who I didn't bother didn't raise the video. Upload. And then A, so you go A times your X value, and then B times your Y value, and that will give you your constant term. Oh, this is why I can't write and talk at the same time. Been a long day. I'm looking forward to my 12-hour day tomorrow. So that looks, I have to say, that looks hideous, right? and it's in your textbook. They've probably done it a lot nicer. I should just cut and paste. But when we do a question, you'll see, oh, this is just so peaceful. Peaceful, Bobby, peaceful. All right, so let's have a look. We are on page, if you want to be playing, 6H, and that would be page 170. So just out of curiosity, Kunal, are you singing while you're at home, or do you just save that for us? What does the class think? Do you think he's singing at home? They're all saying, yes, 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 you're singing. Mac, Will, I think you should learn a song to sing to us when you come back. Eden, maybe they could sing, you could do the doo-wops or the moves. All right, so as you can see here, part A, they tell you you've got your normal vector. Okay, they've got the point, so it's as simple as we say this will be 2x. Oops, simple, and she makes a mistake. 2x take 1y plus 3z, right? And then we just go 2 times the minus 1. I'll write it, don't really want to. Anyway, 2 times minus 1 minus 1 times 2 plus 3 times 4. Okay, and we tidy it up. And now that you're big year 12s, so what have we got? I have to write this, minus 2 plus 12. So now that you're big year 12s, you should realise now how these questions roll. You have your basics and they go, oh, we give it to you. We give it to you. And what's going to happen? Well, you have to try and find some of that information, and they hide it a little bit, and that's, you know, where they all go. So, happy days. All right, let's try B, shall we? So, I've cut off the top bit, but it says find the equation of the plane that's perpendicular to the line. So, we've got a line going like that, and it's perpendicular. Oh, now how can I draw the plane? No, that didn't look really. Yeah, okay, we'll go there. So line is possibly going through. It could go all the way through that plane, but it is perpendicular to the plane. Oui? So would it be, I mean, I think you're geniuses anyway, but basically the direction vector of AB is going to be the normal vector for the plane because it's perpendicular. So do you see what I mean? They're not saying, oh, here's your normal vector. Okay, so we will find AB. Okay, 5 take 2 is 3. 7 take 3, 4. 2 take 1, 1. Okay, and you need, obviously, we've got our, so this now becomes, this is our normal vector, so tick, and then we need a point. So, and it perpendicular to the line which passes through the point A. So that means my diagram is a bit dodge because it's actually A is on the plane. Capito? No capito. Capito? Capito. So your point is your point A, which is 2, 3, 1. So go, you good thing. Do I need to finish? They say no. Well, they didn't really, but I'm saying no. Let's not even write question 2 down. Pressure's on. Bobby, what's the normal vector for A? So now Moses will tell us the normal vector. So Bobby said 2, 3, negative 1. What's the normal vector for B?
3, negative 1, 0.
Correct. Ooh. What about Z equals 2? It's not a trick, yeah. 0, 0, 1, yep. Because it's the coefficient of, the thing is there's no X, there's no Y. So Iman, D, 1, 0, 0. I got you, yep. Capiche? Have a think of 3. So people just had a little bit of a question about 3b, like it was weirdo, because we're wanting to find the equation of the plane that's perpendicular to the z-axis. So the plane that's perpendicular to z is actually your xy plane. And remember, you need a vector that is, so you need the normal vector, so the vector that is perpendicular to the plane, which happens to be the z-axis, which is that. So that's your normal, that's your point, and away you go. All right, next one. Right, so find the equation of the plane that contains these. Are we doing, hello? Are we doing this one? You're doing it by yourself if you want to, but basically we've got a plane again, and we've got points A, we've got points B, and we've got point C, and they're all on the plane, right? This is what we talked about before. So again, you ask yourself, if I want to find the equation of a plane, what two things do I need? I need a point, and I need a normal vector, right? A vector that is perpendicular to the plane. Now, we've got excess points. That's groovy. How do we find a vector that is perpendicular to the plane, right? That's going up, okay? How do we do that? Well, that's when we do the cross product, okay? So we can find AB and we can find AC. I should have looked at what they did in the example, but we'll just have a look in a minute. And when you work out AB cross AC, that is going to give you, we'll use pink, right? It's going to give you this vector here, which is that one, okay? And that gives you a vector that is perpendicular to AB and AC. And then what point should you pick? Well, I would pick A. Winner, winner, chicken dinner. Right? Do you have to pick A? You should be able to pick B or C, and it'll give you, because you've got a perpendicular vector any point on the plane. But because I've used A, I like to just stick with A. It's the front. That's my initial. Anyway. So, yep, oh, they went A, B, and CB, controversial. So, go through, have a look. Oh, no, they did. A, B, A, C, that was for B. There we go. They've used long-handed way to work out the cross product. Again, I say to you, you should be comfortable working it out by hand, but also using your calculator. So, mix it up a little bit. Do it by hand once, check on your calculator, whatever. Please note, though, little tricks to make your life easier. If you can pull out negative, right, instead of using -1, -10, -6, you are allowed to pull out the negative and make your equation look pretty. If you didn't, if you wrote -x, oops, take 10y, take 6z, you know, look, it's the same, but people would just go, ew. It's not very attractive. Okay, so have a go. Notice it's asking you to put it in vector form and Cartesian just to mix it up a little bit. Do you have to do all of them? Maybe pick 2, because I do want to have a look at 5 before we go. A lot of this is going to be, again, read a couple of the examples that sort of make sense, but can I ask you, visualize, right? So if we look at 5, hello, eyes up. So find the equation of the plane containing the point and this line. And you go, Once again, what do we need to find the equation of the plane? We need a direction vector and we need the point. Now, we're quite happy that we have a point. That's A, correct? So we've got that. But how do we get, the normal vector, right? How do we get something that is shooting up perpendicularly? How are we gonna? Cross product of what, my friend? Right, so we need 2 vectors. Now we have this vector, do we not? Because from the line, we know that that vector is going to be 1, -1, and 2. Okay, so our direction vector of the line is 1 - 1, 2, and we're going to have to cross product that with another vector. So we basically need, we've got the 0.32, 1. They're really happy with this 3, 2, 1 and 1, 2, 3, aren't we? But we need to get another vector. We need a point on the line. So how would we get a point on that line? Yeah. Kels? Yeah, so you could just go let t equal 0, right? So from the line, if t equals 0, we've got the point 1, 2, 1, 2, 3. Are they doing it deliberately? Yeah? So now we've got 2 points. You would now find your, let's call that B. You could now find your unit, the vector there, AB, cross product, and that will give you your normal vector. Does that make sense? So every time you do these questions now, before you sort of look at the example, because it will be, example C, example do. But before you look at that example, can you please sort of see, could I sort of solve this without? And some of them it might not be example C, example do. So question 7, did I jump to 7? No, that's fine. So 7, I might have. No, that's right. Find the parametric equation of the line through A and B and find where the line meets the plane. So you're going to find parametric equation of a plane, so of a line. It'll be like x equals something, y equals something. So imagine our little equation that we just had here, right? Imagine we've got this. I've got people not looking, which is bugging me. So imagine we've got an equation of a line here, x equals 1 plus t, whatever. That's what you did, because we know how to get the equation of a line between 2 points, don't we? Get direction vector, use one of the points. So we'd be able to get that easy. How do we know where it meets the plane? How do we find out where any 2 lines, 2 planes, whatever, how do we find out where they meet? You make them equal, so you're going to sub. So instead of x here, you would have subbed in x equals 1 take t. You would sub in for y equals 2 plus whatever that is, yeah? So little things like that, where do we find out? How do we do where things meet? You'll be right. Yeah? So you're just sort of working your way through. As I said, a lot of the examples are quite similar, read, apply, but you are going to have to do a little bit of this because this is a big exercise, right? And try and get stuck in. Don't spend all your weekend doing, don't spend all of your day tomorrow, either part-time work or doing your methods investigation. You have to give spec some. I'm getting a bit sick of you doing the other stuff. We've taken our foot off a little bit. So I'd really like it if we could get to 15. 6, we've got find the equation. So make sure you read your question carefully. We want the equation of a line. And then we're going, well, what do we need to find the equation of a line? We need its direction vector and we need a point. Now, what they've given you is the equation of a plane. Now, when it says the line that's normal to the plane, aka it's perpendicular to the plane. So don't we know that this normal vector, the one that's this is the line we want, right? What direction, what vector is that? 1 minus 3, 4. So the normal, 1 minus 3, 4. The normal of the plane equals the direction vector of the perpendicular line, or we call that the normal line. Right? So that is my direction vector for my line. What point have I got? Well, it tells me. Yeah? But keep always going back and going, well, what's it asking me to find? What do I need? How am I going to get that? And if you're in doubt, draw a picture. Love you. So try and get up to question 15.